So this is going to be our first introduction to the actual physics topic. As I said before, the videos that we did before and the lessons that we talked about aren't really physics exclusive. They're just more of kind of foundational stuff that you kind of need to be able to recognize because it's used in this class, but it's not really the intro of this stuff. It's not the actual science part. We're actually going to start talking about right now with this topic of linear motion. This is going to be broken up into a few pieces. The first one, to introduce the concept of linear motion, I'm going to tell a quick little story called the Heartland debacle. So this comes back in a time when I was first learning to drive. I had just gotten my license, and I was one of a few of my friends who had a car and a license. So I went to my friend's house, and we decided that we want to go to the golfing range. We want to go and hit a few golf balls in order to just kind of hang out and play around. It just so happened that at I had, as I said, I had just gotten my license, so I didn't really know my way around the island yet. I pretty much only knew my town, like going to and from my friend's house. This was also before smartphones, and the only way that we could actually get location and direction to things was to either bring a physical map that we usually had in our car, or to print out a map from MapQuest to get to the location. Because this was a last minute thing, we didn't really have that option. So I tell this to my friends, and they go, "Don't worry, you could just follow me." Well, it turns out my friends aren't really the smartest people because when we split into groups, we had two cars. In one car, happened to have all the kids who knew how to get to this driving range. The other car, the one that I was driving, happened to have all the kids who didn't know how to get there. So right off the bat, didn't really make sense. So this is where we started off at location A. This was my friend's house. This is where we have to get to. Now that I know about driving and I know how to read maps a lot better, the getting to this location is super easy. Like, it's disgustingly easy. The fact that I couldn't get it actually is pretty pathetic. But we didn't get to this location. No, instead we landed here, where this arrow is, a few towns over. So I want to kind of explain a little bit about this. Like I said, you'll see why I'm talking about this in a second. So we get into the cars, and I'm following behind my friend. And again, my friends aren't the smartest because the moment we get to the very first light near the house, pretty much less than a minute into the adventure, I'll say, he runs a red light. The light turns red, and he guns it and completely runs it. Me, being a Boy Scout and abiding by the laws, decide to stop at a red light, believing that my friend would notice that I wasn't following him and pull over and wait for me to come behind him. But instead, he just goes faster. So at this point, my friend, who we're supposed to follow, has completely disappeared. We call up the car to kind of get some directions, and they give us some random directions of side roads, and we get to this location. Now, if you look very closely, you should see that if we continued in our path, we would have actually went to the driving range. But when we told the people the street that we're on, they said, "Oh, I don't know that street, go back." So from this location, we decided to double back to where we started, and then we take directions. This time, I make a wrong turn, and I get to this location. I call up my friends again. They tell me to go back. They give me slightly altered directions, but for some reason I make the same mistake. And then I double down and continue going east until I get to this location. So this is where I landed. Now at this time, my older brother starts calling me, telling me that he needs the car. I was driving the cool car. He was gonna drive the minivan. He didn't want that, so he wanted to switch cars with me. So he calls me up and I don't know where I am. I don't know the towns, anything. Again, I was very young. I don't have a smartphone. I don't have a map on hand. So he asks me where I am. Now, this entire trip, I drove about 44 miles. That is a large that's a large distance to drive to pretty much get nowhere. So I drove about 44 miles. Now, my big question is this important information for my brother to know? Is this something I would tell him that I drove 44 miles? Well, the answer is no. This number makes no sense. The reason being is that this isn't 44 miles straight. I was doing a ton of loops. So this 44 miles is including a lot of backtracking. Instead, what would have been a really good piece of information is to tell him where I started, like the distance from where I started to where I end up. So the distance was how much I drove altogether. The word that we use to talk about where I start to where I end is called displacement. So it turns out my displacement was about 10 miles. Now, the next question is this enough information for my brother to find me? Well, the answer is no, because 10 miles from where he is could be anywhere in this yellow region, so anywhere along this edge. So, what I would want to also include in this description is a direction. So, if I told my brother I'm 10 miles east of where he is or where I started, then he can use that information to actually locate me. I didn't give him either of those pieces of information because, again, I don't really know where I was going. But all in all, eventually I did end up getting saved by my brother. He was able to find me, and I was able to end up going to the driving range. But this story is meant to kind of explain the difference between distance and displacement. They're very similar terms in that they're both measurements of length, but their reasons and their meanings are slightly different. So you want to make sure you know that. So, distance is the total length of the path you traveled. This is a number that constantly goes up. The more you move, it goes up and up. A good example is if you go on a track and you do 8 full laps, then you end up running a total of 2 miles. Again, the distance constantly goes up. It doesn't matter if you're going forward or backwards, your distance is still increasing. In this class, distance and displacement are both going to be measured in meters. Those are the standard fundamental units. All right, so compare distance with displacement. Displacement is actually the straight line distance and direction between where you start and where you end. So it's basically the difference between displace and dat place, displacement. So going back to the same scenario, that if you run around on a track 8 times, well, your total displacement actually ends up being zero because you're going to start and end at the same spot. Another good example, let's say you want to figure out your displacement during the day. Well, you start your day in your bed and you end your day in your bed. So by the end of the day, you were displaced 0 meters. You have no displacement. But if you have a Fitbit or a Apple Watch or something like that that measures and tracks your steps, you can figure out how much distance you covered during that day. So your distance and your displacement are two different things. Distance looks at everything you did. Displacement only looks at start and end and nothing else. Like I said, both are going to be measured in meters, and they're both represented by the symbol D. This really only plays a part in one equation specifically, so when we get to it, I'll make sure to note it. But these are two other examples of distance and displacement. Another thing that you can kind of think of it is that displacement is the shortest shortcut. If you start here and you're told that you have to end at this location, the shortest distance between those 2 points is a straight line going from here straight to that location. It's the shortcut, it's the cheater's cut. That's the displacement. All right. So what I want you to do is you have these four scenarios. For each of the diagrams, what I want you to do is figure out the distance from start to finish and the displacement from start to finish. For choice 4, you're going to start here and then end where this last arrow goes. So you're going to start on the first arrow and go and end here. All right, so pause the video, work on itself, and we'll go over it in a second. All right, so let's actually just do all the distances because they're easy. So scenario 1, we go from here to here. The distance is going to just be 1 meter. That's all I walked. 2, the distance is going to be 1 meter and 1 meter. That's 2 meters. Choice 3, 1, 2, 3. And 4, 1, 2, 3, 4. Easy peasy. Next is displacement. So for number 1, we start here and then we end here. That's 1 meter away from my point. So I'm going to say 1 meter, but I'm going to add the direction up. Choice 2 now is going to be a little bit trickier. So I start at this location and I end at this location. I want to draw a straight line so that looks like this. Now think to yourself, what shape did I just make? I made a right triangle. Think back to math. If I have a right triangle and I have one leg and the other leg, and I'm looking for this angled side, also known as the hypotenuse, I could use Pythagorean theorem to get this. So 1 squared plus 1 squared equals c squared. Turns out that that's going to be 1.4 meters, and then you would give a direction up and to the left. All right. Choice 3. So again, I start here, I end here. These two directions kind of cancel out, so going from here to here is just going to be 1 meter to the left. And then 4, I start here, I end at that same location. Final displacement 0 meters. All right, easy peasy, lemon squeezy. All right, here's the next question. Pause the video, work on the stuff, and we'll go over it in a second. All right, so they say that we start at this location and I end up here. Now they want the displacement of the bus. So I'm going to ignore this path for the most part and just draw a straight line from here all the way to here. So this is my displacement. So I know that this distance is 400, and I know that this distance is going to be 400 because of this. So 400 plus 400 equals 800 meters. Now, one thing I'm missing here is I'm missing the direction to the right. One thing I want to note is that typically with displacement and something like this, you should try to use the directions that are provided to you. So they don't give me north, south, east, or west in here, so I want to try to avoid those directions because I don't know where north, south, east, and west is, but I do know what left and right is. This is to the right, this is to the left. So you usually want to try to use whatever directions they give you. If they're giving you cardinal directions, north, south, east, and west, use them. If they're giving you left and right, use that. All right. Next question. Here's the next one. Pause the video, work on itself, and we'll go over in a second. All right. So best way is to basically just draw it out. So I go 3 south, 4 west, and then 3 north. So my displacement is going to start here and it's going to go this way. I made my arrow dotted to kind of differentiate it from these other ones. So going from here to here, again, the 3 down and 3 up kind of cancel out. So I already know, because this is a rectangle, that this would be 4 meters. So my answer, oh, I already had it drawn, is 4 blocks west. Again, I made a mistake here calling it meters. I wasn't really paying too much attention. Again, you want to use the directions that they give you. They're giving you north, south, east, and west, so you use that. They give the units in blocks, so you want to use that. So 4 blocks west. All right, here's the next question. Pause the video, work on stuff, and we'll go over in a second. All right, so they want us to compare the total displacement to the distance. So again, the distance is this length and this length. That's the distance. The displacement is from here to here. I said before that displacement is always shorter. It's the shortest distance between 2 points. So if you're not traveling along the displacement, you're traveling a farther distance. So compared to the displacement, the distance is longer. Yep. Let me get rid of the, there we go. The distance is longer. In questions like this, I always kind of like to rewrite it a little bit differently. So in my mind, I would have read it as the distance driven is longer than the displacement. So I would have actually reorganized this so that it kind of flows a little bit better. All right, this might be the last question. So pause video, work itself. We'll go over this one in a second. All right, so here we're told that the person runs the length of the football, the basketball place, basketball court. It's 30 meters, and he goes there and back. So from one post to the next post is 30, and then back is another 30. And he does this 3 times in 60 seconds. So they want to know, what is the total distance? So you have to pay attention. So going there and back one time is going to be 30 plus 30, or 60. Do it a second time is it's another 60, and a third time is another 60. So altogether, he traveled a total distance of 180 meters. Now, a follow-up question would be, what was the displacement? So pause the video and think to yourself, what is the displacement of this basketball player? The displacement in this case would actually be 0, because again, he starts and ends at the same spot. He's going there and back. So the 30 there, 30 back cancel each other out. So all in all, doing these back and forth drills, he has 0 displacement, but he does travel a total 180 meter distance. All right. I think, okay, hopefully this is the last question. So pause the video, work on this up, and we'll go over it in a second. All right, this one's a little bit tricky with the wording again, so let's take it step by step. First, let's draw a picture. So going from home base, or the batter's box, to first base, they said is 27.4 meters. Then he overruns it, which is 3 meters, and then he comes back. Ooh, that's going to be a bad color. Then he comes back another 3 meters. So the distance he travels is going to be 27.4 plus 3 plus another 3. So that would be about 33.4 meters. On the flip side, the displacement would, well, he's ending on first base. We already know that the batter's box to first base is 27.4. So this would be 27.4. All right, so now let's go back to the question. The question says compare to the distance, and they want to know the displacement. So the whole idea is that I need to compare this number to the distance. Well, let's see. Uh, One thing that's I can compare this is that the displacement is lower, so it's shorter, and then I can go one step further and figure out, well, how much shorter is it? Well, it's 6. I take the difference, and that's 6 meters. So I could say shorter by 6 meters, or 6 meters shorter. And that's pretty much it. I highly recommend that when you do these questions, you try to break it down bit by bit. Um, it's something that I'm going to try to show as we continue on in this is how to break down these questions into their base parts, because every now and then you will see a question that's kind of worded kind of weird like this. Um, if you keep on taking it step by step, just trying to figure out what information you do have before you go to answer the final question, it should make it a lot easier for you. The other thing that I want to mention is that all these questions are coming from the regions. So these are all regions questions that have popped up on previous tests. Now, the one thing that I want to mention though is that these are multiple choice questions. So if you're sitting here thinking, how was I supposed to know that? Well, first, as we continue on in this class, you will start to see wording like this and you'll start to get used to it. So from there, from experience, you'll understand what you're going to do. But the second part is the fact that you would have seen the multiple choice questions, and one of them would have been 6 meters shorter, or 6 meters longer, or something like that. So you could have done that as well. All right. Like I said, that was the end of this video. We'll continue on with this discussion for this topic later. Again, send me messages on Remind or after during school or during when the extra helps. Good luck and have a great day.